Hey guys, sorry I missed today. I have a video for classwork which will also count as homework. And so let's go ahead and begin. This is classwork number 7. It's attached on the assignment in Brightspace. And let's go on. This is classwork number 7 again. This is the Word document I uploaded. I'll write my notes down here. I usually write onto the side already. I already made some specific notes. But let's take a look at definition from a book by Thompson, 1994. We know they are a multiplicative comparison between two fixed quantities. Ratios. Rates of change also express multiplicative comparison, but the quantities they are compared can vary. So what we're looking at is Thompson defining a rate as a set of infinite many ratios. In other words, a rate is a constant ratio that could be abstracted to describe equivalent ratios. So for me, part of the understanding rate is that a rate is a specific type of ratio. I think that's reasonable. And a rate can express infinite number of rates. So if you were to say you travel 30 miles per hour, by that statement of rate, you're also saying that when you travel 60 miles, you would have traveled a length of time of 2 hours. And if you traveled for 4 hours, you would have traveled 120 miles. So within a rate is infinite number of ratios, and a ratio is a specific situation. I think that's a reasonable way to look at it. Let's take a look at the first one. Consider the following. A runner runs 32 miles in 4 hours, but doesn't change his pace. Is this an example of a ratio or a rate of change? Within this idea of 32 miles in 4 hours, I believe you guys can all determine the rate, but this specific example gives us one of the many ratios that are hidden within that rate, if that makes sense. And so this is simply this is a ratio, and it's a specific ratio derived from the rate. So number 1, excuse me, this is a ratio. All right, let's move on to number 2. You pass a gas station, you see $3.50 per gallon on the sign. You ask your students, what does this mean? What do you think will they say? Well, they'll say it's $3.50 per gallon. That's my first thought, which wasn't too insightful. My second thought was that it's a rate, which is reasonable, because if you buy 2 gallons, you're paying $7. And within that rate, you're going to come up with an actual ratio of how much you buy. I always wonder what my students will say. I'm not sure what they'll say. This is more of a discussion-based question, so I'm going to leave it at that. I would hope we could discuss like how they view it is a way to find how much any amount of gallons of gas you buy will be determined by that specific rate. But when you go to the store or the gas station and buy specific amounts of gas, that will be your ratio. All right, let's move on to another question. I'm going to zoom in a little. I think that would be a good idea. Maybe a bad idea. All right, we'll try it. To make a punch, Austin mixes a half a cup of passion fruit concentrate with 2/3 cup of water. If he wants to mix the concentrate and the water in the same ratio to make 28 cups of luscious Lilikoi punch, how many cups of Lilikoi passion fruit concentrate and how many cups of water will Austin need? Now, within that question, which is a great question, we want to look at 2 samples. First is Grayson's, and if you want to pause the video, that's great. I just want you to have a chance to inspect Grayson's work. Check his arithmetic as well. And then check Eileen's work, which is on the back. Come on, Eileen, that's a lot of work. But hey, we just want to analyze it within the framework of Grace and Eileen, how do you think these students conceptualize the situation? How were they thinking about it? What were they reasoning? And how about ratios and reasoning about rates? Explain. So my first thought was I probably should do the problem. So let's take a look at the Lilikoi. We have, in my take on it, is we have a half unit of passion fruit for 2/3 of water. Yep, I'm on the camera. And I want to find an equivalent ratio for that. So I'm going to multiply top and bottom by 6, which gives me 3 passion fruit units for 4 water units, which in this case is cups. So then, obviously, I'm going to lead towards how much for, I believe it was looking at 28 cups of lush punch. So if I want 28 cups of passion fruit, the question is, how much water do I need? And I think you see one way to reason through this. All right, so when we get there, we have a situation where it is not a friendly fraction, and we will end up short of taking algebra, which would just be cross-multiply and solve, which we're going to avoid, meaning we're going to have to resolve different ways of looking at this problem. So, oh, where's my other sheet? Oh, well, that's okay. Oh, there it is. Sorry, just one moment. This is problem 3, and I think we're good there. Okay, good. The Lilikoi, the water, and then the total punch. So if we use half a cup of Lilikoi, we use 2/3 water, if we use 3/6 and 4/6, and you'll see we get a 3:4 ratio, which is good, and it's the same thing we got looking at it up here before we got that unknown. And then we can take a look at it a different way with a graph. Good, it's coming through. And we know that we have 4 units of water and 3 units of the punch, or Lilikoi. Oh, I should have put the 3 over here, make it more sensible. Now, if I was going to say, and this is how I think about it, if I wanted my units to be in 1, and this is a 3, and I wanted this to be a 1, do you agree that's exactly 1/3 of that unit? So if I want to decrease this and get it per units of 1, I would decrease this by thirds, and so my unit rate here, or of my line, would be just as you'd expect to be over 4/3. But just thinking about it is, this is a third to get it in units of 1, right? So this is trying to make it into a unit rate. So what does that mean? It means water will equal 4/3 units of, 1 unit of water will be 4/3 units of Lilikoi. So I guess if we went algebraically to do this, I would say 4 Lilikoi equals 3 water. And we want to be able to add these 2 units together to equal 28 units of punch. So that would be equal 28. And then